Hi everybody. What I have here is the problem that asks you to figure out the volume of a dry gas of oxygen. And what that means is the following. Remember when we had a test tube and we bubbled in carbon dioxide and we measured the volume? Well, when we have the volume of gas in here, notice that the gas is not only the gas that we bubbled in, but also the water vapor that's also the water that evaporated into there. And that water vapor is bouncing around and creates its own pressure. So it has its own partial pressure, okay? So what you need to do is to find the pressure of the gas minus the water vapor that's in there, find the total pressure and subtract it from the water pressure, and you'll get the pressure of the gas that you're trying to study. So let's take a look. A sample of oxygen collected over water at 25 degrees Celsius. So there it is, the vapor pressure of that water is 22.8 mmHg, millimeters mercury. The wet gas, which is the gas plus the water vapor, occupies a volume of 7.28 liters at a total pressure of 1.25 bars. If all the water is removed, what volume will the dry oxygen occupy at a pressure of 1 atmosphere and a temperature of 27 degrees Celsius? Okay, let's go backwards. If they're asking us for a volume and they're giving us a pressure and temperature, we know that the variable that's missing is moles. So we've got to find the moles of the oxygen by itself. But they're giving us everything else. They're giving us pressures of everything else, but I think we can get there. Here I first started out with pressures, and that actually didn't work. Here's me saying, need moles. So let's go straight to moles. Okay, so here we go. What I did here is this, folks, is that I solved for the moles of water, pressure times volume times R times T. So I did earlier. I did definitely find, converted everything into atmospheres. And the pressure of the water, the 23.8 mmHg, is 0.0313 atmospheres. And there it is. Did the math, and I got 0.0931 moles of H2O. Okay, and I'm solving all of this for the original container because that's what we're starting with. Now for the pressure total, I have 1.23 atmospheres, 7.28 liters. I got that 1.23 atmospheres because I did solve from bar to atmospheres, which is a small conversion, divided by R and T, and I got 0.366 moles total. To find the moles of the H2O, we got to just subtract the total minus the moles of water, and there it is. The moles of O2 is going to be 0.36 moles, 366 moles, minus the 0.00931 moles of H2O, and I got 0.357 moles, and that is moles of O2. Let's see, let's put that in there, moles of O2. Then it's just a PV equals nRT problem. V equals nRT over P, plug in your numbers, and you get a volume of 7.99 liters. Okay, there you go.